Morning and Sairam to everyone. In last video we have finished our third chapter, gravitation in physics. So in this video we are going to start our new chapter, work, energy and power. Work, energy and power. So the topics which we are this chapter I have divided into three parts. Work and in first part we will do work, in second part we will do energy, and in third part we will do power. So basically I have divided this chapter in three parts: work, energy and power. So in this video we are going to cover all the related topics to work. That means in this video we are going to cover work. Is this clear? So I will ask you some simple question like, what does work mean to you? Are you doing work when lifting a weight, walking with a bag grocery in your hand, completing your homework assignment, writing essay? After finishing this video, you are able to give this answer in a physics, according to the physics concept. Is this clear? So see, this guy is working. Well, he is going to office to work, as it may seem. Clear? Pushing the stationary wall with a force. Force exerted to the right, no distance more. Is this guy working? Yes, he seems to push the wall, but no, he is not working. To know why he is not working, let us know few things about work and work done. I told you, after finishing this video, you are able to give answer according to the physics concept. Clear? So let us start. We have already studied force and motion in our previous chapter. So, whenever a force makes a body move, then work is said to be done. Clear? For doing work, what is required? Tell me fast. For doing work, what is required? For doing work, energy is required. For doing work, what is required? For doing work, energy is required. So, when the work is done by human beings or animals, then the energy for doing work is supplied by food, which they eat. And when the work is done by machines, the energy is supplied by fuels or by the electricity. So, when work is done, an equal amount of energy is used up. Basically, for doing any type of work, what you will require? You will require energy. Now, living thing gain energy from the food, what they eat, and non-living thing again energy from the fuel or from the electricity. And it is very clear that whatever amount of work is done, that much amount of energy is used up. Is this clear? So let us start with work. See, basically if I will talk work, basically work is any physical or mental activity. Clear? But if we are talking about in a scientific language, work is done when force produce motion. When force produce motion. For example, an engine moves a train along a railway line. It is said to be doing work. A horse pulling a cart is also doing work. A man climbing the stair of a house is also doing a work. So this is all the work. Is this clear? Basically in scientific language, if you will work is said to be done when you apply force, there should be some motion. Is this clear? If F force is applied on a body in a different direction of displacement of the body, and the body undergoes a displacement d in the positive direction, the work done by the force is defined as. So with this we can define the work as the product component of force and the displacement. Is this clear? And the magnitude of this displacement. If a force is applied on a body in a different direction of displacement of the body, and body undergoes a displacement in the positive direction, the work done by the force is defined as the product of component of the force in the direction of the displacement and the magnitude of this displacement. Clear? Now work. So with this we can write the definition of work. Work is defined as the product of the force and displacement. Work is defined as the product of the force and displacement of an object in the direction of force. In the direction of force. Formula of work is W is equal to, you will represent work with the help of capital W. Force into displacement. F represent force and S represent displacement. Is this clear? So I told you how you can find the unit. The force of unit of force is Newton and it is meter. So the unit is Nm, but Nm is equal to joule. So unit of work is joule. You can represent joule with a capital J. Is this clear? Work is defined as product of the force and the displacement of an object in the direction of force. Formula of work is W is equal to F into S, where W stands for work done, F stands for force, S stands for displacement. Clear? The unit of work is Nm and Nm is equal to joule. So unit of work is joule. Is this clear? Now unit of work. The unit of work is Newton meter, which is written as Nm. The unit of work is called joule, which can be, I told you, Nm is equal to joule. Clear? So definition of joule is when a force of 1 Newton moves a body through a distance of 1 meter in its own direction, the work done is known as 1 joule. Clear? When you applied 1 Newton force to any object and that object covered the distance of 1 meter in its own direction, that time that work done is known as your 1 joule. Is this clear? Now your 1 joule is equal to 1 Newton into 1 meter. So 1 joule is equal to 1 Nm. Is this clear? 1 joule is equal to 1 Newton into 1 meter. And 1 joule is equal to 1 Nm. Clear? Now, thus the SI unit of work is joule. The SI unit of work is joule, which is denoted by letter J. And it is a scalar quantity. Clear? It is a scalar quantity. Scalar quantity means we will not consider direction. We will consider only magnitude. The condition for a force to do work is that it should produce motion in an object. The condition for a force to do work is that it should produce motion in an object. For example, a man may get completely exhausted in trying to push a stationary ball, but since there is no displacement, the work done by the man on the wall is zero because there is no displacement. If there is no displacement, in that case the work done by the man or by any object will be zero. Is this clear? I am reading this slides once more. Listen carefully. The unit of work is Newton meter, which is written as Nm. The unit of work is called joule, which can be defined as follows. When a force of 1 Newton moves a body through a distance of 1 meter in its own direction, then the work done is known as 1 joule. Basically, your 1 joule is equal to 1 Newton into 1 meter. 1 joule is equal to 1 nm. 1 joule is equal to 1 nm. Thus, the SI unit of work is joule. Thus, the SI unit of work is joule, which is denoted by letter J. Which is denoted by letter J. Work is a scalar quantity. Work is a scalar quantity. Scalar means we will only consider magnitude. We will not bother about direction. The condition for a force to do work is that it should produce motion in an object. It should produce motion in an object. For example, a man get completely exhausted in trying to push a stationary wall, but since there is no displacement, the work done by the man on the wall is 0. Is this clear? Now, work done against gravity. Our next topic is work done against gravity. The force of gravity of Earth pulls everything towards the surface of Earth. So, if we lift a book from a table, we do work against the force of gravity because gravity acts towards the earth. And if we are lifting a book, we are taking book upward. So that means the direction is opposite. So we are doing work against gravity. Is this clear to you? So, when a body lifted vertically upward, then the force required to lift the body is equal to its weight. So, whenever the work is done against gravity, the amount of work done is equal to the product of weight of the body and the vertical distance through which the body is lifted. Whenever, so with the above equation, with the above information, we can write whenever work is done against the gravity, the amount of work done is equal to the product of weight. Is equal to the product of weight of the body and vertically distance through which the body is lifted. So, your work done in a lifting body is equal to weight of the body and vertical distance. Is this clear? So, W is equal to mgh, where your W stands for work done, m is your mass, g is your acceleration due to gravity, and h is equal to height. W stands for work, G stands for gravity, M stands for mass of the body, H stands for height through which the body is lifted. Clear? Now numericals. How much work is done by a force of 10 Newton in moving an object through a distance of 1 meter in the direction of force? Here we know that we know that the formula of W, work done, is equal to force into displacement. Here force is 10 Newton and displacement is 1 Newton. So 10 into 1 is 10 joule. So the work done is 10 joule. The work done is 10 joule. Is this clear? Now calculate the work done in lifting 200 kg of water through a vertical height 6 meters. Here you have to calculate W. You know that here work done against the gravity. So formula is W is equal to M into G into H. Clear? We know the value of M, it is 200. The value of G is given to you, it is 10. And height is 6 meter. So 200 into 10 is 2000 into 6 is 12,000. So W is equal to 12,000 joule. Is this clear? So thus the work done is 12,000 joules. Now a car weighing 100 kg and traveling at 30 meter per second stops at a distance of 500 meter, 50 meter, decelerating uniformity. What is the force exerted on it by the brakes, and what is work done by the brake? So in order to calculate force, what we have to find? But first we have to find acceleration. Initial velocity is given to you, u is given to you here, u is 30 meter per second. At the last car will stop, so your final velocity will be 0. You have to calculate a, and s is equal to 50 meter. So we know that v square is equal to u square upon 2as. When you will solve it, you will get the answer as a minus 9 meter per second square. Now we know that F is equal to, now you have to find force, so you know that F is equal to m into a. Clear? M is given to is 1000, a is minus 9. A is minus 9. So 1000 minus 9000 Newton. So we have F is equal to minus 9000 Newton. We know that W is equal to F into S. So 9000 Newton. Here minus 9 represents your retarding. So this minus sign will go. So 9000 into 50. The answer will 4,50,000 joule. Is this clear? So work done is 4,50,000 joule. Some more examples are here. You are helping to push your mother's heavy shopping cart with a force of 50 Newton for a 200 meter. What is the amount of work done? We know the force F is equal to 50 Newton and W is S is equal to 200 meter. W is equal to F into S. So 50 and 200 is equal to 10,000 joule. So 10,000 joule or 10 kilojoule. Now our next topic is work done by a force acting obliquely. Basically, in many cases, the movement of body is at angle. See, here it is an angle, na? So, to the direction of applied force. For example, when a child pulls a toy car with a string attached to it, the car moves horizontally on the ground, but the force applied by the child is along with the string held in his ground. So basically in that case W is equal to S. We can't find W is equal to S. Here some angle will be there. So force F is resolved into two rectangular components. One is acting in a vertical direction, does not displace the body, and second is work done by the component is 0. Clear? So F cos acting in a horizontal direction displaces the body. In that case, W is equal to F cos theta into this S. Clear? So whenever there is a 90-degree angle, in that case your work is 0. See, you will understand with this. The work, basically a work done is divided into three types: positive, 0 and negative. Positive work done, 0 work done, and negative work done. Now when it is positive, when it is negative, and when it is 0. Basically the work done is positive if the force acts on a body in the direction of the motion. In that case, your W is equal to Fs cos theta. In that case, cos theta, the value is 1. Because here cos 0, angle is 0. So, your formula is W is equal to Fs. Clear? When there is the work done is 0. For example, एक खुली जब सामान उठा के लेके जाता है, क्लियर, तो उसका बेस क्या है, उसका हेड और सामान में तो कोई मूवमेंट नहीं हो रही ना, सामान तो उसके सर पे ही है. तो इन दैट केस योर cos 90 इज देयर. Clear? In that case, cos 90 is there and the value of cos 90 is 0. So whenever there is force act the body in the direction of force, in that case your cos will be 90 and cos 90 is 0. So if the cos 90 value is 0, so work done is equal to 0. Clear? And when there is, so for example, if you are applying force from this side, so the body should be move on this side, but the body is not moving this side, the body is moving this side. So in that case, cos 180, the value of cos 180 is minus 1. So the formula is W is equal to minus Fs. Understood? Basically, your work done is divided into 3 parts: positive, negative and 0. Whenever there is positive work, that means wherever you force applied in same direction, the object is moving. In that case, the angle is cos 0 and the value of cos 0 is 1. So the formula which you get is W is equal to F into S. Clear? When there is a when you force applied perpendicularly. So in the case of perpendicular itself is 90 degree. If there is 90 degree, so the cos 90 is 0. The cos 90 is 0. So whenever you applied perpendicular force, the work done is 0. And the next one is negative. In which direction the object move opposite to the force applied direction. So in that case, the angle will become cos 1 minus 180, and the value of cos 1 minus 80 is minus 1. So the formula you will get is W is equal to minus F into S. Is this clear? Now, example, work done by gravitational force on the satellite is 0 because of force act perpendicular. Clear? To the direction of motion of the satellite. Is this clear? So with this, I think everything is clear to you when you will say work done when there is a motion. Clear? Produce a force applied, and when you applied force perpendicular and hence there is no movement, there is no motion, there is no change in the position of that particular object. For I gave you the example of Cooley one. In that case, your work done is 0. So according to physics, what do you mean by work done? When there is a motion, or when you will apply force, there is a motion of any object. In that case, you can say that work is done. With this, I think the concept of work is very clear to you. Clear? Thank you and Sairam.